Hi guys, so today we're going to do a little bit of algebra review, and we're also going to expand on some things that you saw back in Algebra 1. So today is going to focus on factoring and solving quadratics. So the first thing we're going to look at is factoring, and as we talked about in class, this is very, very important for what we're going to do in this class second semester and also what you're going to do in your future math classes. So when we factor, it's kind of like we're reverse foiling. Okay, we're trying to figure out what factors will multiply to give us the binomial or trinomial that we have. So whenever it comes to factoring, your first step is to always take the GCF. All right, we always want to take the GCF. If there's not a GCF, we can move on from there. So if there's not a GCF and we have two terms, one of the things we look for is something called a difference of squares. So difference of squares is in the form of a squared minus b squared, where there's a minus sign in the middle and you know the square root of both terms. So something like example A is a difference of squares. The square root of 49x squared is 7x. The square root of 64 is 8. So that factors into 7x minus 8 and 7x plus 8. All right, then we'll go ahead and look at B. And again with B, our first step is to take the GCF. It's hard right now to see that this is a difference of squares. But if I take that GCF out, then I'm able to factor. Because now I do know the square root of 25x squared and of 16y squared. So that would give me 5x minus 4y and 5x plus 4y. And that 2 that we factored as a GCF, we just keep on the outside. All right, then we move on to C. Again, this is still a difference of squares because I still know the square root of x to the fourth. That would be x squared. Square root of 16 is 4. So 1 is plus and 1 is minus. And then from here, the reason it's important to be really quick to recognize difference of squares is just because they come up so often. So x squared minus 4 is going to factor into x plus 2, x minus 2. And now this is factored completely. All right, D is another example of a difference of squares. Even though it looks different, the square root of c plus d squared is just c plus d. And we know the square root of 81 is 9, so we know the square root of both terms. There's a minus in the middle, so this factors into c plus d plus 9 and c plus d minus 9. So all of those are examples of difference of squares. All right, so the next ones we're going to look at, some of these have two terms, some of them have more. But again, our first step when it comes to factoring is always to take our GCF. And when we say GCF, we mean of the numbers and also of the variables. So if you look at E, both 10 and 25 are divisible by 5. If you look at your variables, x to the fourth and x to the seventh, the greatest common factor that could come out is x to the fourth. If 5x to the fourth is divided out of 10x to the fourth, I'd be left with 2. If it's divided out of 25x to the seventh, I'd be left with 5x cubed. All right, if we look at F, all three terms there are divisible by 3. So 3 comes out, and I'm left with this trinomial. From there, we would see, hey, does that trinomial actually factor? So I would look to see what multiplies to negative 10 and adds to negative 2. In this case, there isn't anything, so that is not going to factor any farther. And then G, even though it looks intimidating, G is just a GCF question. Again, we look at what's the greatest common factor between 3, 9, and 12. So that's going to be 3. And then we're going to look at each variable. Well, a cubed, a to the fifth, and a to the seventh, the most that can come out is a cubed. Out of my b's, the most that can come out is b squared. And then out of my c's, the most that can come out is just c. So if that divided out, of the first term, both 3 and 3 would be 1, a cubed and a cubed would be 1. B to the seventh divided by b squared would be b to the fifth. C to the fifth divided by c would be c to the fourth. Remember, when you divide those exponents, you subtract what they are. So like if I have, for example, c to the fifth over c, that's c times c times c times c times c over c. So one of those cancels out and you're left with c to the fourth. That's why it works how it does. All right, then we go to the middle term. 9 divided by 3 would give us 3. Then I'd have a squared, b, c cubed. Then on the last term, I would have 4 as my coefficient. If I had a to the seventh and I took out a to the third, I'd have a to the fourth. and b squared and c are already divided out. All right, and then again on h, first step is GCF. All three terms have a 4. All three terms have an x. So that would leave me with x squared minus 4x plus 4. Then from there, I would look and see, does that trinomial factor? So what multiplies to 4 and adds to negative 4? And that would be 2. So x minus 2 and x minus 2. Another way I could write that, though, is x minus 2 squared. And that leads us into the next type of trinomial that can be a little bit easier to see. So I'm going to go back up on our notes. And if you notice where it talks about this perfect square trinomial. So the one we just did was in that form. It was x squared minus 4x plus 4. So a perfect square trinomial means you have three terms if you take the square root of the first term and the square root of the last term. If you multiply them together and multiply them by 2, if you get the middle number, then it's going to factor into that perfect square trinomial. So basically the same binomial that's just squared. And that's going to come up a lot when we do difference of squares next class. So let's go ahead and look at a couple more examples of this. All right, so I is a good example. So look at the square root of the first term, that's 3x. The square root of the last term, that's 2. Well, if I multiply those together and double them, I get the middle term. So this is going to factor into 3x minus 2 squared. The sign is going to be the same as that sign that's in front of the b value. All right, so now let's look at j. Again, square root of the first is 9x. Square root of the last is 2. If I multiply them together and double them, I would get that middle term. So this is a perfect square trinomial. So 9x minus 2 squared. All right, so now we're going to look at what happens when the a value is not 1 and it's not a perfect square trinomial. Now, there are a lot of different ways to learn factoring in these cases. If you have a method that you're using that works well for you consistently, continue to keep doing it. But if you're not quite sure how to do these, I'm going to show you guys what is most likely the method you saw in your Algebra 1 classes. So our first step is we multiply the first number and the last number. And we want to find two numbers that multiply to that value. We also want two numbers that are going to add to the middle number. Once I know what those numbers are, in this case that would be -6 and -4, I'm going to rewrite this problem. But I'm going to change the middle number into those two new numbers that I just came up with. So -10x has been replaced with -6x minus 4x. Then from here, I'm going to use a process called grouping. So I'm going to look at just the first two terms. Out of those first two terms, 3x is my GCF. If 3x gets divided out, I'm left with x minus 2. Then I look at the next two terms. Whatever sign is there, I'm going to keep. And then I take my GCF, which is 4. If I divide out that -4, I'm left with x minus 2. And it would be minus because if I went back and FOILed it, I need to get what's already there. So now if my parentheses match, which they do, that's your first factor. Everything that's not in the parentheses, well, a little too far there, everything that's not in the parentheses is your second factor. So my second factor would be 3x minus 4. All right, so that's just an extra example we did in class, but we'll just go ahead and do that one real quick. So we're looking for numbers that multiply to 18 and add to -11. So those would be -9 and -2. So I'm going to split up the middle into those two numbers. I'm going to do my grouping. So out of the first two terms, 3x comes out. Out of my next two terms, -2 comes out. My matching parentheses are my first factor. And the other one is my second factor. All right, so on these ones, very similar process. But what's going to look a little bit different here are the terms. we're still going to follow the same steps. We just need to keep our terms consistent throughout this process. So I'm still going to look for two numbers that multiply to 2 times negative 12 and add to negative 5. Well, those numbers are negative 8 and 3. So I'm going to rewrite the problem, and I'm going to keep the variables the same as they were. So since it was x to the 4th in the first one, it's still going to be x to the 4th. Since this was x squared, my new numbers will still be x squared, because I'm still rewriting the exact same problem. Then from this point, I'm going to look at my two terms here. 2x squared would come out. I'd be left with x squared minus 4. Then out of these two, 3 would come out. I'd be left with x squared minus 4. My parentheses match. Everything that's not in the parentheses is my other factor. All right, looking at m, again, same process. 6 times negative 15 would be a negative 90. The middle is 1. My two numbers that multiply to negative 90 and add to 1 would be 10 and negative 9. So I'm going to rewrite this problem, and I'm going to keep the variables the same. So even though it looks a little bit different than the questions we're used to factoring, the process hasn't changed. We're just keeping our variables consistent with what they originally were. So out of those two terms, 2x comes out. Out of the next two terms, keep the minus. My GCF would be 3y. That leaves me with 3x plus 5y. My matching parentheses are one factor. Everything that's not in the parentheses is my other factor. All right, so this one's a little bit different. This is kind of what we call factoring in disguise. This is actually a very easy to factor question. It's just written in a way that makes it hard to see. So what I'm going to do is I'm going to replace this x minus 2 with a different variable. I don't want to use x because x is already there, so I'm going to pick another variable. I'm just going to say u, because that's just a variable you'll see in the future. So I'm going to let u take the place of x minus 2. So that would make this u squared minus 3u minus 40. Well, now this is a really easy to factor question. A is 1, so I just need the numbers that multiply to negative 40 and add to negative 3, and those would be negative 8 and 5. And now I factored that. The problem is that's not really the factored form of my original question, because my original question didn't have u. My original question had x minus 2. So I need to go back and replace that u with the original x minus 2. Then from there, I can simplify it if it simplifies. And in this case, it will, because x minus 2 minus 8 is just x minus 10, and x minus 2 plus 5 is just x plus 3. All right, so again, one more, very similar to the ones we've done. We're looking for numbers that multiply to 18. They add to negative 11. So those two numbers are going to be negative 9 and negative 2. Rewrite our problem. Keep our variables consistent. Out of the first two terms, 3xy would come out. Out of the next two terms, minus 2 would come out. So my factors would be xy minus 3 and 3xy minus 2. So factoring has a lot of purposes. One thing we'll use it for in this class is we'll use it to simplify when we get to rationals. But another practical aspect of factoring is using it to solve quadratic or polynomial equations. So when we solve by factoring, we have really two extra steps than what we just did. So the first step in order to solve by factoring is to set your equation equal to 0 if it's not already. So on A, that's already done for us. So then we're just going to factor like we've been factoring. Well, in this case, my first step is to always take my GCF. My GCF is 4x. So 4x comes out. That leaves me with x minus 5. Then my last step, if I'm solving, is that I'm going to set each factor equal to 0 and solve. So I would do 4x equals 0 and x minus 5 equals 0. So one solution is x equals 0. Another solution is x equals 5. All right, looking at B. Again, first step, make sure it's equal to 0. Then I can factor this. A is 1, so I'm just looking for what multiplies to 9 and adds to 6. That's 3 and 3. Set my factors equal to 0. Well, there's just one factor because this was actually a perfect square trinomial. And I get x equals -3. All right, on C, it's already equal to 0. So I'm looking for numbers that multiply to 6 times 12 and add to the middle number. Those numbers would be -9 and -8. So I'm going to rewrite my middle term. I'm going to do my grouping. So my two factors are 2x minus 3 and 3x minus 4. So then to solve this, I'm going to take each factor and set it equal to 0. So I would get 2x equals 3, which means x equals 3 over 2 is one answer. And x equals 4/3 is my other answer. All right, again, another example just that we did in class. Same process, we would set it equal to 0 first. I would factor. So my two numbers that multiply to -10 and add to -3, -5 and 2. I would do my grouping. The only thing that's common there is a 1. So my factors are x plus 1 and 2x minus 5. So my zeros, my solutions, would be x equals -1 and x equals 5 over 2. All right, so besides factoring, there are a lot of other methods to solve quadratics. Another one we're going to do now is solving by square roots. So this is the best method when there's only one squared term in my equation. And what I mean by that is if you have an x squared without just a regular x, or if you just have an x with something in parentheses squared, and there's no additional x term outside of that. That's when solving by square roots is going to be the best method. So in order to solve by square roots, very similar to just solving a typical equation. I want to get the x squared by itself, just like I would normally get x by itself. Well, my first step would be to add 3, and then divide by 2. And then at this point, I would square root both sides. The thing you have to remember, though, whenever you take a square root, the answer is not just the square root of 5. The answer is plus or minus the square root of 5. All right, example B, very similar, one slight difference though. Instead of just an x squared, now you have something in parentheses squared. That's okay. We're still going to try and get this part by itself before I take the square root. What I don't want to do is distribute that 3. I can't distribute that 3 because it's not normal parentheses, because we'd have to do the exponents first with PEMDAS, because that whole thing is being squared. So I need to work to get this part by itself. So what I would do is add 10, divide by 3, and then I can take the square root of both sides. And the square root of 9 is not just 3, it's plus or minus 3. So that means that 2x would equal 5 plus or minus 3, and then I can divide by 2. Now, if this was something with a square root in it, we could just leave it in this form and simplify from there. But since we're talking about actual integers here, this is not simplified all the way. So we do need to go ahead and simplify this and actually find what those values are. Well, one of those would be 5 plus 3 divided by 2, and the other would be 5 minus 3 divided by 2. So we are going to go ahead and actually say what those numbers are. All right, so now let's go on to this to C. Again, our goal is to get what's squared by itself first. So I'm going to subtract 5, divide by 2, Square root both sides. So when I square root this, I'll be left with 3x minus 4, and the square root of 8 is going to be plus or minus the square root of 8. But we can also simplify the square root of 8. So remember, with square roots, if they're divisible by a perfect square, the square root of 8 is divisible by 4. So I can rewrite this as 2 root 2. So again, think about your perfect squares. 4, 9, 16, 25, 36, 49, etc. If you have a square root and it's divisible by one of those perfect squares, we can divide that perfect square out in order to simplify it. All right, from this point, same steps. We'll add 4 and then divide by 3. All right, so then our last method that we're going to look at, that's just an extra example. The last method we're going to look at is the quadratic formula. This is the one most people tend to remember from Algebra 1. You do need to make sure that if you don't already remember this formula, that you learn it, okay? It's really important that we know quadratic formula. Quadratic formula is nice because it does always work, but it's not always the fastest method. That's why we want to look at factoring and square roots, because those are much faster methods. They just aren't always going to be able to work for us. And then next class, we're going to look at another method called completing the square, which will also help us to solve quadratics. Now, one piece of the quadratic formula you probably talked about in Algebra 1 is the discriminant. So the discriminant is the thing that's inside the square root. And what that does is it tells us about our answers. It doesn't necessarily tell us what our answers are, but it gives us information about them. If that discriminant is positive, we know there will be 2 real solutions. If that discriminant is 0, we know there will be 1 real solution, and specifically that solution will be the vertex. We also know if the discriminant is negative, there will be no real solutions, and next week we're going to get into a little bit more detail about what that actually means. All right, so using the quadratic formula here, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. A is the coefficient of the squared term, b is the coefficient of the x, c is the constant. So this would be negative 8 plus or minus the square root of 8 squared minus 4 times 1 times negative 4, all over 2 times 1. So now I can simplify. This would be negative 8 plus or minus the square root of 64 plus 16, which is 80, over 2. And then we need to simplify. Now, a really common mistake on quadratic formula is people at this step trying to simplify those numbers. We cannot do that yet. We cannot simplify the bottom number with quadratic formula until after we've simplified their square root. In order to simplify these numbers, there also has to be a number in front of the square root that we can also simplify. Well, let's go ahead and simplify the square root. Think about what perfect square 80 is divisible by. And 80 is actually divisible by 16. So 80 is the same thing as 16 times 5. Square root of 16 is just 4, so I can rewrite this as 4 root 5. And now both numbers at the top are divisible by 2, so I can go ahead and reduce this, and I get negative 4 plus or minus 2 root 5. All right, let's go ahead and look at B. This will be the last one. So quadratic formula, so negative 20 plus or minus the square root of b squared minus 4ac all over 2a. So this would be negative 20 plus or minus 400 minus 8, which is 392, all over 4. This one actually does reduce. That may not be one you know, but that actually is going to reduce to 14 root 2. And then both of those numbers at the top and the number at the bottom are all divisible by 2. So we're going to go ahead and divide them all by 2. So I'll get negative 10 plus or minus 7 root 2 over 2. And those are my solutions to the quadratic. All right, so we're going to look at one more method for solving quadratics next class, and that is going to be completing the square.